Okay, so in our last video we talked about how to use a simple knowledge graph and how the CSSP could utilize knowledge graphs for red and blue team exercises because penetration testing typically starts with some form of initial reconnaissance where basic intelligence is gathered and information about the target is put together. And we talked about how easy it is to represent that sort of information in a graph or a graph database. And there are lots of these out there. There's, Apache Tinkerpop, obviously, for enterprise scale stuff, TinkerGraph, OrientDB. We're obviously using Nero4j here because it's easy to use, easy to learn, and it's free. There's also really powerful cloud-based graph databases out there for AWS, AWS Neptune, Cosmos in Azure, I think, is the other one. And you can also use Microsoft SQL Server. Some of the later versions of SQL Server have graph capabilities built in. So what we've done here is we've taken our previous graph and we have mapped out and connected these on-prem resources to a few cloud assets. A staging area, a prod area, we can call those AWS assets, and an iWork Facebook page here. So a couple of interesting things can be observed now that we have external resources added into our graph. Both Frank and Kristen here, remember those from the last exercise, are members of the AWS admin group, and so they have full privilege to manage the prod and staging environments in AWS. Our other actor from the last exercise was Mallory here. Mallory does not have administrative rights or is not in the AWS admin group, so she has no access to manage either the prod or the staging environment. But the real question here, and what we're trying to illustrate with this, is can she? Can Mallory gain access to the AWS admin group and therefore the prod or the staging environment? So we're going to take a look at the entire graph. I'm going to expand that with the Cypher query, and we might see some interesting attack paths that Mallory may be able to leverage. So let's go ahead and do that. Okay. So let's get this moved around a little bit so we can see. All right. So in the previous video, we showed that there was an attack path for Mallory to compromise Justin, who was a domain administrator, and given that level of privilege, she could then compromise the Earth, Neptune, and Saturn hosts, right? So in doing so, Mallory could then impersonate Kirsten or Frank here through this host, okay? And then, because both Frank and Kristen have permission to the AWS accounts, Mallory could, for instance, steal the AWS cookie and perform a pass the cookie attack into and gain access to these assets here. So another option, obviously, would be to add herself into the AWS admin group here after gaining domain administrative permissions. So hopefully this kind of gives you an idea of how powerful a good graph model can be for sort of holistically managing and securing assets across both on-premise and cloud-based environments. And in our next video in this series, we're gonna show you really how to get your cloud assets into a graph model. Pretty much every cloud provider out there offers a REST API interface and command line tools that allow you to query and enumerate information about the resources that exist in those cloud accounts. And what we're going to do is we're going to use the identity and access management system within AWS to create a user group to export the data as JSON file. And then we're going to convert that JSON file into a CSV, and we're going to import that CSV file back into Neo4j to create a comprehensive graph model of our AWS cloud footprint. So really, instead of hand typing in these cipher queries to create the nodes and the relationships between them, we're going to get a data dump directly from AWS, and I'll show you how easy it is to build that model. So stay tuned for that video coming up next.